My name is Robert Hodges, and I'm going to be talking about the open source analytic universe, data and Anecdata. So Anecdata are obviously little stories I tell that might or might not be true, but illustrate the principles of open source analytics. I think you'll enjoy them. So let's go ahead and dig in. Just a little bit, get this to click, just a little bit about me. I'm the Altinity CEO. So I've been running Altinity for about 3 years. For the purposes of this conference, I'm a database geek. I've been working with databases since 1983, mostly on applications, but on a bunch of related topics as well, like replication, connectivity, security, other issues like that, testing, another great one. And I've been working on analytic databases since 2013. The first one I really played around with was Hadoop, followed by Redshift. About Altinity.com, we're the sponsors of this concert or this conference today. Really proud to be able to welcome so many talks. We're an enterprise provider for ClickHouse, so we're firmly in this open source database world and connected with a lot of the tools that make open source database applications work. And we have a cloud offering and of course offer services to people who run things on-prem. Talk a little bit about related topics, but that's enough about Altinity for now. So let me just go ahead and dive in. Where I'd really like to start this talk is to talk just a little bit about the history of data warehouses. These are databases which are designed to handle very large scale reads on large amounts of data and bring back answers quickly. This is a field that's been dominated by proprietary software, starting from products like Sybase IQ, which I knew when I was working back at Sybase, to Vertica, to Redshift and Snowflake. Incredible innovation, a series of steps that made these better and better, leading to the current cloud databases that we see today. But in every case, it was proprietary technology. So an interesting thing, though, has happened over the last 10 years. Which is we're in a new phase. So you could think of the history as having particular steps, and we're in the next one. And in this particular case, what's happening is we have, over the last decade, we've seen the rise of very, very large data sets consisting of a lot of small records like web logs, network telemetry, huge amounts of market and diverse sets of market trading data. So these data sets are arriving, and for businesses to process them, they need to meet some very, very strict requirements. So for example, these events are coming at tremendous speed. It's not uncommon to see event flows arriving at 5 to 10 million events per second. The second thing is we store enormous quantities of them. Again, trillions of events are not uncommon, even in small businesses. And finally, to answer questions usefully, both for analysts as well as building feedback loops into the world, we need to answer questions in less than a second, regardless of how big the data set is. And in fact, in special cases, we need to be able to provide answers in tens of milliseconds. This is a completely new set of requirements and a completely new world of data. And what it has done is it has favored a new breed of open source database. Now, open source databases are nothing new. We have MySQL, we have Postgres, we have Mongo. They've been around for a long time, but they've mostly been doing transaction processing or managing documents. The idea that we now have analytic databases is something new. So these databases themselves are not new, but their prominence is, and they include 4 databases that I list here, plus others. These are ones that are featured at our conference today, include Presto, which can scan very, very large amounts of data from diverse sources, and then 3 examples of what we call low latency data warehouses. Databases that are designed to answer questions very, very quickly on potentially large amounts of data. So these databases have been growing in popularity, and one of the ways that we can actually get some real data on that is we can go look at GitHub Records. This is a graph which is based on data that was pulled from the GitHub events streams. This is a data set that's available. It was kindly reduced to ClickHouse tables by Alexei Milovidov. It's about 3.5 billion rows. And for example, we can, with this data set, we can go ahead and graph out the growth of GitHub watchers. And what we see is a steady increase in the number of watchers or stargazers on these GitHub projects over the last 7 to 8 years. And in fact, these are becoming some of the most popular data warehouse or database projects overall on GitHub. So this growth is continuing, and you can see this acceleration of growth as we enter the 2020s. Another even more interesting thing about these databases is that they're driven by enormous numbers of contributors. This is a graph that shows unique GitHub contributors each year who contributed a PR that was actually merged with each of these databases. And you can see these numbers growing. Each of the databases that we have has around 100 or more regular committers each year. And in fact, with ClickHouse, there's been this kind of amazing growth to where ClickHouse actually has more committers at this point than Elasticsearch does. That was the previous champion in these numbers. So as these databases have become more popular, they've connected up with a set of other open source communities backed by their own, other open source projects backed by their own communities. These include software for loading and transformation, ranging from Kafka to RudderStack. A number of these are featured at the conference today. These get the data in fast. And on the other side, there are projects that enable visualization and use of the data. And I've just given a few examples here. There are literally dozens of projects that can help with this. I've tried to restrict it to the most common ones, as well as things that are featured at today's conference. And what this has enabled is, in fact, there's now a pretty common pattern for the low latency for these low latency analytics that's illustrated by this application from Mux, where you have some event stream loading data, putting it into a database, making it accessible to a database like Presto, like ClickHouse, like Pinot, like Druid, and then having a bunch of analytics that are visible to users on the other side. So this pattern is increasingly common. One of the things, though, that is particularly important here is these applications are large and they're kind of complex. And as a result, one of the things that we see in the analytic universe is we're starting to overlap with another big community that's out there and driven by open source. And that's containers. So remember these guys called Docker? About a decade ago, they cooked up the idea of being able to package up Linux processes with their software dependencies. This was a container. So this is a really important innovation in app development. And what has happened is that it has, of course, sort of evolved into what we call cloud native apps, which run on Kubernetes. Kubernetes is a management platform for containerized applications. And what's interesting about Kubernetes is it represents kind of a middle ground. There used to be kind of stark choices that you could either run things on racked hardware, perhaps with virtualization like VMware running on top of it, or you could go to the public cloud. Kubernetes offers this interesting compromise where you have basically what's something that looks an awful lot like a cloud, but it is portable. Moreover, it has a bunch of features built into it that allow distributed applications, which are a way of characterizing all these analytics apps that we work on. It allows them to run very efficiently. So we've seen this grown considerably. Right now, about half the customers at Altinity are using Kubernetes in one form or another to host analytic applications. It's a very it's a very profound movement and has moved out and is now moving out into the mainstream. What this is doing between these databases, the ecosystem software for ingest and for visualization, as well as Kubernetes, is we're now reaching a stage where SaaS applications increasingly include built-in analytics, and not just any analytics, not just simple reports, but high-performance analytics across large sets of data. Here are just some examples. A recent application that I saw that really impressed me allows traders to look at vast pools of trading records. And these are actually represented as more or less unstructured data with some indexing on top of it. But they are able to look directly at the raw data, sift through it, and build custom investment strategies. This is something that would be impossible without these high power analytics. Another example, log management. This is increasingly coming on to these new low latency SQL data warehouses. So being able to read log records, detect problems, and then interactively slice and dice the data to zero in on what might be causing a problem in a large cloud system and correct it. And there are literally hundreds of companies that are using this strategy, and many SaaS applications that do this for people as a cloud service. Another example, network management. This is another pattern where these SQL data warehouses are particularly well suited to deal with NetFlow records or CDN telemetry. An application that I work with regularly actually has built-in appliances that are used on-prem to manage software-defined WAN performance. A couple more, games. So big generators of data, very heavy consumers of products like Druid and ClickHouse and Pinot. And what they're interested in is optimizing ROI on games by doing things like adjusting game awards policies. And then finally, security. This is an issue that is of wide interest across the entire IT industry. And what we're now seeing is these very large systems, often running to hundreds of nodes, that ingest records from live systems, things like access logs, things like system logs, and enable people to to quickly recognize problems and also develop strategies to protect against them. I think that in some ways, though, that these business analytics that I've described are just the beginning of what is really happening with these open source analytics, these new databases and the software around them. Let me give you an example that kind of hits home. This is a satellite picture of the Caldor fire. It's a big one of many fires that broke out in California earlier this year. Next week or later this week, I'm actually going to be meeting with some of the folks who are developing new systems to try and detect fires and provide real-time information about them using satellite data. So we have this real-time world that needs better management, and this will depend on being able to integrate data from satellites, drones, historical weather feeds, as well as ground-based sensors to manage forests in a much more effective way that can withstand some of the challenges that we have in front of us. So returning to this open source analytic picture, this is a really interesting history that we're all part of. And I think when this history is rewritten or written again in 2030 and people look back at the last phase, what's going to be there is these open source analytic databases. So, and as well as Kubernetes, and the databases that we've talked about in this talk, Druid, Presto, Pinot, ClickHouse, are going to be some of the databases that will figure in this history in a big way. So at Altinity, we're proud to be part of this. Organizing this conference was one of our ways, one of a number of ways that we try to contribute to this development and contribute to this broader community. Thank you so much for listening to this keynote. I really appreciate your attention and hope you enjoy the rest of the conference. Talk to you soon.